Hi guys, welcome. Next class is the test. So let's review. It says, what properties are specific to parallel lines and perpendicular lines? So we had a discussion question. You could answer a couple different things, but we know parallel lines, we can use this symbol, right? So if we wanted to say line A is parallel to B, we would say it just like that. Line A is parallel to B. I think you could say something here about two vertical lines on the same plane are always parallel, two horizontal lines are always parallel. And lines that are not vertical or horizontal are parallel if and only if their slopes are the same. So same slope. So that would be something like, let's say A, B, C, D. Let's say this is line E and F, and this is line G and H. So if slope E looks about maybe up 2/3, then the slope of F would also have to be up 2/3 for them to be parallel. So this can work forward or backward. We could be told their slopes are the same, so then we come to the conclusion they're parallel, or we can be told they're parallel, so we know their slopes are the same. Now, we also know that slopes can be negative. So slope H and G maybe are -3. Slope G looks like maybe -3/2. And also slope H looks like it's the same, -3/2, based on kind of how I drew it there. And that's probably everything we learned in parallel lines. So now if we think about perpendicular lines, so I'm going to use a different color, perpendicular lines. If A, B, C, D, E, F, G, H, I, okay, so I'm to I and J. If line I and J are perpendicular, then it could be that just I is vertical and J is horizontal. So any horizontal and vertical line are perpendicular, meaning to meet in a 90°. And also if they're not vertical or horizontal, kind of like our line E and F, we can go back to line E. If the slope of E is +2/3 and the slope of F, right, slope of F is -3/2, then those would also meet at a 90° angle because their products are equal to -1. So let's see. What I mean by that is their products are equal to -1. Let's take a look. 2/3 times -3/2. Yeah, those would equal the product -1. So technically, we have a special name for this, and it's opposite reciprocals. Right? One's positive, one's negative, and one is the flipped upside down version of the other one. Cool. All right, so any of that, you don't have to write down all of that, but any of that would have been great to write down for our topic essential question. Now let's get to our vocab words. So it says angles that are outside the space between the parallel lines. So that's making me think of exterior. So I'm considering any of these, right? Angles that are outside the space of the parallel line that line on the same side. So I want outside, but then also on the same side. So that would be same side exterior. Same side exterior angles. All right, so I used that one. A blank intersects coplanar lines at distinct points. So a I think that's our transversal. I'm going to put transversal for now. That's this idea of our transversal. Okay. Two angles inside a triangle. Okay, that's interesting. So two angles that are inside of a triangle that correspond to a non-adjacent exterior angle. Yeah, so that was the two remotes add up to the exterior angle. Two remotes add up to the exterior angle. So they're talking about the two angles that are inside. They are talking about the remote interior angles. I like that word interior. So remote interior angles. Okay. 5, blank lie on the same side. Okay, we like the same side of the parallel lines and are in corresponding positions. So that means that that would go with corresponding angles. We can just abbreviate CAP, corresponding angle postulate. Okay, we got that one down. Angles between parallel lines that are non-adjacent and lie on opposite sides. So they are between the parallel lines, so that means they're inside, and they're not adjacent and they lie on opposite sides, so that the word alternate is the same as opposite. So that's our alternate interior angles, right? Alternate interior angles. Last one, angles between parallel lines that are on the same side. Okay, so that would mean angles that are between the parallel lines but are on the same side. That has to be like this, you know, same. Both of those are on the right and they're between the parallel lines, so that would be same side interior angles. Same side interior angles. Nice work. Okay, so we just ended up not using this one and this one. All right, let's check out page 2. So lesson 1 and 2, it says a quick review when two parallel lines intersect a transversal. Just gonna highlight that. When two parallel lines, so here are the parallel lines, and that's the space between them. There are angle pairs that are formed that have special relationships. We said there were 5 special relationships. So I'm just going to list those really quickly. It's AIAT, AEAT, SSIAT, SSEAT, and corresponding angle postulate. Okay. So we talked about there are 5 angles that are created, and these angle pairs are either congruent or supplementary. So I'm actually going to highlight the congruent ones are the ones that don't start with an S. And the supplementary ones are the ones that actually start with an S. Okay. So it says which angles are supplementary? So that would just be supplementary to angle 2. We notice angle 2 is obtuse. So to be supplementary to an obtuse angle would be any acute angle that is formed by these 8. Any acute angle that is formed when I have parallel lines. So we notice that would be 1 and 4, 5 and 8, and that's why they came to that answer there. All right, check out the next video for